So yeah, we thought it would be fun to share some kind of just internal experiments that we're doing and just get any feedback or stoke any excitement. This is something that has been on my mind for a while, um, and I'll go over a little bit about what it is and kind of the problem it's trying to solve. So on Tableland, obviously, the network provides a kind of cloud-like SQL endpoint, so you can query data. Although in practice, when people develop applications, they need somewhere to put their APIs, or so they're not just querying directly from the front end for everything. And also on the network, it's not so easy to do data transformations. So from a back end, you might want to return HTML or SVG images. There's a lot of options for that. Really, just kind of, this is serverless functions, basically, is what we're trying to accomplish. So the goal of this experiment was just to see how viable that was to deploy on Tableland. I'll share a link to this, to the repo. The README has a lot of overview about this sort of the why and the components of the repository. So the design of this is largely based on some of the architecture from Cosm Wasm, which is based on Wasmer, which is kind of the leading Wasm runtime. There's a few others out there, but Wasmer has kind of been pushing a lot of the features, specifically for blockchains, because they internally have a way to pretty easily measure the work that it takes to execute a binary. So this is what you would build like a measure of gas on. So literally you can assign a cost function to certain WASM operators and then add that up. And it's not, right out of the box, but it's pretty close to that. So Wasmer is what is used to build the smart contract functionality in Near, Cosm Wasm, obviously. The Filecoin VM is built on Wasmer. So there's just a big community of folks leveraging these kind of internal features. So it provides this sandbox where you can do things, and I'll kind of show how I built the bridge to be specific for Tableland. And you can configure, can it talk to the outside world or not? And anyway, I go into a lot of these little things in the README, but in the interest of time, I'll just show you kind of what the experience was that I was going for. So this is like an example JSON API. So I have right now a local Go validator, Tableland validator running, and I've seeded it with a bunch of data. It's like pet data and the pet's owners and where they live. So this is just a simple endpoint here that has parameters at the end. I have it set up to filter by like the type of pet, so I can go in, I can see all the birds. And you see that took a little bit of time to load. That's because it was loading the binary from cold. So that's referred to as like a cold start in serverless function nomenclature. So now if I do it again, it's going to be super fast because it's the binary is built in memory. And let me just show what that example looks like. So with Tableland Functions, with its experiment, the interface I designed to feel somewhat like Cloudflare Workers, specifically Workers RS. This is all done in Rust because it's really the best way to work with Wasmer. There are bridges to other languages, but you get all the low-level stuff out of the box with if you do the language bindings in Rust. So yeah, this is what it looks like. You simply create a single fetch function here, and you'll find a similar kind of flow on other serverless or edge function environments like Supabase, Versal. Really, any serverless function environment has a similar kind of handling where we want to receive a request at our fetch. These are HTTP request objects. And then we have some context that we can use to do things in the method. We could, of course, just like return, hello world in here or something. But in the bridge that I built for Tableland, I built in just a simple Tableland read-only client. So this should feel familiar to people who have used our SDK before. So you can make queries, you can use our read options like unwrap or extract or what kind of the format you want the response to come back in. So here I'm just making a query to two tables internally, and I'm just joining them. And then we're going to take one of the path parameter here and use that to filter on the type of pet. So this router I modified from Cloudflare Workers RS, and it's just a nice way to build up like sort of an HTTP like interface to do handling like this. So we can do your basic server HTTP server handling. So yeah, that's what's going on there. If I was to give it like some bad request, it's going to do the query because it's hitting that endpoint, and then I'll get some error back from the validator saying it's a bad query. Or I can come up with one that's not part of the function. It'll give me a not found like that, or the home root is hello from Tableland. So there's another example I have. I'll try and blast through this. I don't have a ton of time. This is one that's just rendering HTML. And it's just, we can respond with any kind of like headers or whatever in here. So this is the same query. And again, we're doing a cold start here. So, and we can look at dogs or whatever. So this was meant to kind of get the wheels turning on the idea of doing server-side rendering with a Tableland function. That would require some most likely like a JavaScript runtime, which is totally doable if you wrap it like QuickJS or something like that. If you wrap that into a WASM binary or assembly script, there's some things to explore there, but this is the basic idea. We can return HTML. And let's look at maybe one that's a little more interesting. So here's a function that uses an SVG template, and we're going to kind of emulate doing all of a NFT's metadata with the function. So we have this ID parent, this ID pattern. This will match just returning the JSON metadata. And then if we append an image, append /image to that, we'll render an SVG that's based on the live Tableland data. So I'll quickly go through and build this just to show you how it works. I'm going to build the function, the binary. I'm going to publish it to IPFS. This could be some other data layer too, like something more kind of verifiable like Filecoin. Then I'm going to post that CID to the Tableland tables, a modified version of the Tableland tables contract. the validator is going to listen for this publish function event that has the CID of the function in there. And then it's going to ping Tableland Functions, the daemon I have running here that's listening and caching and doing all the compilation and everything. It's going to pull from the data layer, the binary, instantiate it, cache it, and start serving it. And then we'll be able to query it over its CID path. So let me just go into here, build this thing, add IPFS, get the hash, and go over to VS Code here. This is the very simple function I added to Tableland tables. It's literally just emitting this event with the CID. And I have a little helper script. This publishing would be built into SDK or CLI or whatever. So we got that thing. Go back over, you can see that, I don't know if that's too small, but you can see that the worker picked up that function. So now in theory, it should be queryable. So we'll duplicate this tab. We'll get one of the endpoints here, so you can see we've got our NFT metadata. You can see another one. The table this is built off of is just a simple players table where every row represents a token and it has a single column which represents health. And then you can see that its image is here. I'll come back to this TBL and we can hit the image and it'll put simple SVG here, and we can go see the different tokens. If I request this a bunch of times, it's going to run out of gas because when I instantiate the function, I'm giving it some top-up level of gas internally, and then we basically the work that the function's daemon does to execute it gets subtracted from sort of its quota. And you can see here, there's kind of two measures of this gas. One is external. This one is based on the size of the query. This is kind of work done outside of the function. And this is tweaked from CosmWasm. Basically, we want to include any external work that was done. So like right now, it's a basic measure of that, which is just the size of the SQL query and the size of the response. That's not really sufficient for like a production use of this, but maybe it's that we time internally to go validate, or we time the execution or something like that. But this could be some algorithm. Internally, this is the sum of all the WASM operations that were done. And also we are limiting, you can limit the memory that's going on in here. So right now it's like 16 megabytes for each function. So if it goes over that, it's not going to take down the function's daemon or something. And yeah, the way that the gas is leveraged comes a little bit down to how we envision, if we take this experiment further, the functions playing into the network. It could be that you literally just retop the function every time. So the purpose of the gas is more like a security measure. So you can't just do some infinitely, like recursive thing in your function. It could be part of the payment flow for reads. And yeah, so that's just, it's all kind of there to be leveraged. And I think that's about it. So, oh, I did want to mention the SVG. So I wanted to mention the TBL on the image. Here, I'll just restart this so we can get some more gas. Do a call start. So there, it just pulled the function from a file system cache. And yeah, so the image here, this is just totally just a future fun concept where in the past we had talked about, some kind of TBL protocol on the network. It's never quite made sense to me in terms of just tables or queries, because a table is kind of already addressed on the network. It doesn't, referring to it, is usually like you're querying it or something. So having it content addressed in that way doesn't quite make sense to me. But in the context of functions, I think it does, because these functions could be executed against any validator on the network. So it's sort of like, pick your validator to execute it on, and that's similar to like an IPFS type protocol. So I'll stop there. I know I kind of just blasted over, but yeah, if anyone has any questions or just a totally experimental thing, I thought it would be fun to share some internal experiments with folks.